All right, so what if we did these translations together? If we had a horizontal translation and a vertical translation all in the same function. So that actually is very common. When you first learn about it, you might learn about one of the translations first, then another one second. So what we're going to tackle in this example video is both translations together. So our question is, what information do the constants h and k provide about the graph of g of x equals the absolute value of h, or x minus h, and then a plus k on the end? So we have a specific example. Compare the graphs. First, we'll look at this first one. G of x equals the absolute value of x minus 4 and then minus 2. So when we look at this, we want to notice it's an absolute value function. So it's going to be a V-shaped graph. And then this minus 4 and this minus 2 is going to translate the graph. The minus 4, that's your tricky x. So we actually are going to go to the right 4. And then that minus 2 on the end is a vertical translation. We're going to go down 2. So if we look at our graph, here's the parent function. We're at 0, 0. This whole graph is going to shift to the right 4 units. So 1, 2, 3, 4. And then down 2 units, 1, 2. And that's where our new vertex will be. You can see the vertex is 4, negative 2. So that because we started at 0, 0, the shifting is going to shift your vertex and we end up at 4, negative 2. That would also shift your axis of symmetry. Horizontal shifts will carry the axis of symmetry along with it. So now our symmetry line goes through the vertex at x equals 4. Yeah, I think that's all we had to say about that one. Our second function, we have g of x equals absolute value of x plus 5 and then plus 1. So what do we notice here? It's an absolute value function, so it's a V-shaped graph. We're taking the absolute value of x plus 5, so that plus 5 is going to be a horizontal translation because we're adding a constant into where the x is. Tricky x, though, it's going to go to the left 5 units, and then the plus 1 on the end means we're going to shift and translate up 1 unit. So let's just see that visually here. We've got our parent function, vertex is at 0, 0. G of x is going to be left 5 units and up 1 unit. So if I go back to my origin, I'm going to go left 5, 1, 2, 3, 4, 5, and up 1, and there's the new vertex at that ordered pair 5, 1, negative 5, 1. Axis of symmetry would go through that, that vertex, so your axis of symmetry would be x equals negative 5, in case anyone asked. And that's how it works when you have both translations in the same function. So just a couple quick ones for us to try on our own here. Find the vertex of the graph of each function. So we want to, again, just take some notes, some observations. Absolute value function, so it's a V-shaped graph. We have an x minus 1. That minus 1 in with the x is going to shift your x's. Because it's minus 1, we're going to go to the right. Actually, let me write that out. We're going to go to the right 1 unit. The minus 3 on the end, we're going to go down 3 units. And if our vertex was at 0, 0, and we went to the right 1 and down 3, our new vertex is at 1, negative 3. All right, g of x, or our second g of x function, absolute value function, so V-shaped graph. We got an x plus 2. Tricky x, if it says x plus 2, we're going to translate to the left 2 units. And then that plus 6 on the end, we will shift up 6 units. So our vertex of our new function, remember we were at 0, 0 in the parent function. Now we're going to go to the left 2 and up 6, so our new vertex will be at negative 2, 6.